Now, I'd like to introduce our next speaker, Nikita Semenov from MTS. Nikita, the floor goes to you. Good day. Hi everyone, my name is Nikita Semenov. I'm the manager of the machine learning department in the AI R&D center of MTS Telecom Operator. Today we'll be talking about voice as a UI, and we'll be talking why this is the new era of user interaction. Let us talk about the brief history of the interaction between human and machine interfaces. There are two types of human-machine interfaces, input and output. Pretty much two options here. If we look into the history, let us look at the things like perfect cards. Maybe not the most convenient interface to interact with a machine, but it allowed doing certain routine things, like a punch card or a tabulating card. So, that interface, of course, got better, and from punch cards, tabulating cards, we went to keyboards, mices, buttons, wheels, scroll wheels, barcode readers, gamepads, etc. The next stage is graphic UI and sensor screen, touch screens, image scanners, cameras, etc. So when we transition from pressing the actual physical button to pressing the virtual object on screen and reading visual information from it. What else? As a matter of fact, for the time being, all of the interfaces are getting better, and the next obvious step for them is the natural update or transitioning to more habitual, to human beings way of interaction, which is just speech or voice. Let us figure out why voice is convenient and it's a good alternative to keyboard. First and foremost, this is a very convenient input method. We do not need to get distracted. We don't need to look at the keyboard. We don't need to touch the device. We just can dictate and say stuff. And the learning curve for this input method is not steep at all, because voice input does not require some specific knowledge from us or specific skills. And it is more appropriate for a broader range of users, such as elderly people or those who don't know how to type or cannot write, or somebody who is just illiterate in terms of computers. And of course, this is very good for wearable devices, like a smart bracelet or smartwatch without screen, so that you can easily input certain commands. And it's just quick. A human being can pronounce 150 words a minute compared to typing of about 40 words a minute. However, this input method is very promising. However, it's not well integrated into our daily life, and there are main four reasons to that. First of all, low precision, low accuracy of speech recognition. At the moment, current tools for recognition are not at the level appropriate for mass market and mass use. Although it's getting better, it's approaching the threshold. Then, natural language understanding, NLU. Language is complex, and lots of information is hidden in the context. And people might not express their actual intention or use references to express what they actually want, while actually asking them, play the same that I was playing yesterday at noon. This is the command that we could see here, sorry. And these solutions are quite costly to integrate. I mean, keyboard is cheaper than the web server for speech analytics and processing. And of course, there is certain latency at the moment. which has to be minimized so that the systems would be giving quick and realistic feedback. Let us talk about where voice UI is applied. Of course, we know smart TVs, smartphones. Let's not talk about that in detail. That's pretty familiar to you. Let's talk in more detail about social robots. Not very common devices in Russia, but in other countries, there's this aspect of voice interfaces. Social robots. What's the specifics of these sorts of robots? It's not that they execute some routine tasks, but they build social ties and make social interactions to human beings. So these are the members of the socium. They express their emotions, they react to emotions, and their main functions is interaction and communication. We should also highlight voice interfaces in the cars. This is very common today, but I believe that this is a thing that will go at the background as the self-driving cars become more and more common. I mean, speech is useful where you cannot use other methods of input, or other methods of input are illegal. Any distraction from the situation on the road in a car can cost you your life, or somebody else's life. So voice is a very convenient interface to make input in a car without being distracted from the road. But we can also find new applications for voice input. Smart house, so that you can manage all of your devices, starting from lighting and ending with cushions, with voice. That probably is the future. Another exciting story is medical diagnosis via voice, which again facilitates the diagnostic process and can redirect you to the doctor when necessary. And another important point is smart toys. There are different applications for that. Toys, educational toys, which can do different things, speech training, movement training. Or, for example, fine motor skills and manual dexterity training. Here are the ways to use, here are the spheres where voice input is being used. Look. This is the graph that shows the significance of voice input for their industry, for their devices. If we go deeper into what actually is voice recognition, voice dialogue, voice interface, there are two parts to that. Part one is something that installed on our device, the front end, as you know it, which does pre-processing of the sound. If there's the actuated phrase, for example, we understand that this is the some certain request or query or call. We can remove echo, remove distortion of the reflected signal, and that signal can be sent into the cloud for processing. The valid signal is actually being sent into the cloud, is being analyzed. So we do the back-end speech processing and generate the answer, the function to generate the answer of natural speech, and it's something that the user can hear. What's the problem with this approach? Is that it's all cloud-based. The processing is happening in the cloud, and we can only work with the text. We use the actual signal after distilling it from the environment. So the environment is not being used. It's only discarded. So it's all text-based at the moment, but the future must be multimodal. We should not only use text or only sound or only one of the two. And that's applicable for both input and output devices. That is actually easy. It all buttons down. It all comes down to natural abilities of the human ear. Human can type 40 words a minute, speak about 150 words a minute, and read about 240 words a minute. But best UI can be created via the use of different modalities. What if certain information we provide with the speech, some information that is hard to perceive via the ear will be visualized via the screen of the cell phone or on a TV screen? That will actually facilitate interaction with the user. But let's not confine ourselves only to these ways. If we talk about the output, let's talk about the input. Input can also be multimodal. Let me show you a few examples. First, something that's pretty common, in-car assist, when we have a virtual assistant installed in the car system. And of course, there's a way to interact with that smart assistant in the car via voice. But every time we speak to that assistant, we need to pronounce the keyword like Siri or Alyssa or OK Google or Alexa. Multimodality allows us to avoid that because the background might be noisy or there might be false positive. But we can add a camera. So, for example, if the driver is looking into the camera and saying the key phrase, that means that the voice assistant needs to be activated. So we're adding another modality, video. So we're doing face recognition and can read the intention of the user in the car. An alternative example is offline retail, when we have a shop. And there's the consultant robotic assistant that can allow certain items. But users mostly don't go to the shop to get assistance for a specific iPhone or Samsung. They want to know the difference between several items, and often they don't know even the title of the item. They will just say, what's the difference between this and this? And finger point. So here we can actually use this sort of recognition model that reads the movement of human body and understand to which items in the shop the user actually points. So voice interface is not actually voice-based interface. Voice user interface is not per se voice-based. It's just voice-enabled. They use this sort of interface does not only use voice, but voice is not the only element here. What other problems and challenges we see here? First and foremost, AI improvement, because at the moment voice assistants are highly specialized. They can do some routine tasks efficiently, but if we want to create the solution for all of the possible ways and business uses and context, we need to develop a more general AI. Just because this sort of solutions are not very well scaled, and we need to apply lots of effort to advance it for other domains. Next, language resources. That's pretty self-contained. This sort of solutions are mostly based for 10 or 20 most popular spoken languages: Russian, English, French, Mandarin, etc. But if we speak about not widely used languages such as Punjabi or Indonesian, millions of people speak that language and write that language, but there are no language recognition models for those languages. So the mission is to develop voice recognition models for hundreds and hundreds of languages. And now we're facing the problem of chicken and an egg. We don't have users, we don't have services. We don't have services, we don't have users. So we'd have to solve this problem eventually, and future is multilingual. And of course, let's not forget about privacy. Trust is an issue. Every time we go to the shop and get the recommendation, we always keep in mind this idea whether the recommendation is honest and not prejudice. There might be some background intention, so trust is an issue. Another issue is security. Our voice interfaces can access most of our private services, such as email, calendar. So, therefore, we're facing the problem that we need to develop some security tools for voice input. For example, I have a smart speaker at home, and anybody who would request that speaker about my calendar can find out where I'm going tonight, or check my email. The future of this sort of interfaces should be more protected.
Maybe voice biometrics or something like that. This is a very important story. Another important story is confidentiality. Because we say some things, and some of those things are not exactly recognized by voice recognition systems. Sometimes there are false positives, and from this false positive, they can record some information, send it to a server, and most people can worry about the situation that their speech is being recorded, sent to a server for processing. So it's a very serious problem, especially for the development of things like of configurative learning or some edge computing. When we put some processing to devices, then from devices we send some faceless data. And finally, I would like to speak about trends. These interfaces are the interfaces of the future, but this future should be a little bit different, not as these interfaces are developing right now. First of all, this future should be multimodal. It depends on the input and output. The future should be moved in a direction of edge computing. Not like everything is being processed in the cloud, but when some processes are being processed on a device, you should have a possibility to divide different users who speak with a speaker. Because if you have this speaker in a house and you have a big family, you should need to discern and personify the output and interrelations with every family member. And speaking about the relations experience with such an interface, it should be consistent, it should be continuous, and it should be complementary. This is the end of my presentation. Thank you very much for your attention. Thank you very much. We have learned a lot of new and interesting things. And I've had a question. Isn't there a problem with acquisition of data sets for teaching learning models that you apply in your technologies and your interfaces, and how this problem is being solved by you, and whether you can solve it in the next year or two? Well, the problem does exist, but everybody solves it differently. The main objective is the main goal. As for me, I can give you several cases. For example, how the Amazon was releasing one of their first versions of smart speaker. They gave it to all the employees under the idea of the speaker, and they made them test these. So after collecting the proper data set, correcting the bugs, but there are other ways of solving this problem. For example, if you have SDLs, you can install these devices in offices and ask people to record certain commands. If we are going to operate with modern methods, it's going to be much simpler to collect a specialized data set to collect speech for some specific voice interface, and then fine-tune a big general model for the peculiarities. We don't need very big interface for this and super big data set. But the quality will be comparable if we will have good learned ML with a big data set.